How do we describe matter? How do we change matter? Both properties and changes can be categorized one of two different ways, physical or chemical. Let's look at some examples. I'm sure that the majority of us in our kitchen somewhere have a bottle of vinegar, or we definitely have a bottle of salad dressing, and the grand majority of salad dressings have some vinegar as a main ingredient. To a chemist, vinegar is a solution of acetic acid. So I abbreviate solution, S-O-L-N. I'll rewrite that so it's a little clearer. And we'll talk about what exactly a solution is with classifications of matter. But it's a solution, it's a mixture of water and acetic acid. If we were to describe vinegar, we could write down some different observations or characteristics or properties. Well, vinegar is a clear liquid. You can see through it. It is colorless. Now, these are different things. Definitely think about that, and you can ask if you need any assistance with that. You could measure out a certain volume, let's say 10 milliliters of the solution, and get the mass of that. And we could actually divide these, couldn't we? Mass divided by volume to get the density of the vinegar that we were dealing with. We could taste it. Now, of course, in chemistry, we don't. But we know that as an ingredient in a lot of salad dressings, it delivers kind of that sour. Acids taste sour. So these are what we would call physical properties. A physical property is, and you can read along, but we can make that measurement, we can make that observation without changing the chemical identity of the substance. To make these assessments, we in no way, shape, or form are changing the chemical structure or the identity. The different numbers of elements that make this up stay the same when I make all of these descriptions. Let's move on to something else. Baking soda, again, something that I'm sure that you have somewhere in your kitchen, either a box of it for baking, or perchance you have, a Betty Crocker brownie mix that has some baking soda in it somewhere in your kitchen. Well, baking soda to a chemist is sodium bicarbonate. It is white in color. It is a solid at room temperature and pressure. It is usually presented in a powder form, very, very small particulates. It tastes bitter. Again, not that we're encouraging you in the lab situation, but we know in the kitchen we're okay, but a tiny bit is all that you need. It tastes very, very bitter. To make all of these descriptions, I in no way, shape, or form changed this chemical identity. We know it's a solid at room temperature and pressure. Well, what if we would add heat to it until we got it to its melting point? Now, ionic compounds have relatively high melting points. So, we're talking probably hundreds of degrees Celsius. Forgive me for not looking it up. I don't know it off the top of my head. So if we knew the melting point, let's just say, I'm going to just guesstimate, is maybe 475 degrees Celsius. It's probably much higher than that. But if we converted it to a liquid, would the melting point, if we're reporting it, the temperature at which it's a liquid, now, is it still sodium bicarbonate when we've liquefied it? Absolutely, absolutely. Remember, it is still a ratio of 1 sodium for every 1 hydrogen, 1 carbon, and 3 oxygen. You've just changed the relationship of the particle attraction and the kinetic energy. Yeah? That's it. You've not changed the chemical identity. So we just have to make sure that we're being careful with that. So all of these are physical properties. So what is a chemical property? Well, chemical property is only seen when you are changing the chemical identity. So what would be an example of that? Well, I'm using these two substances because I think most of us are familiar with the volcano reaction, where we take vinegar, which the active ingredient in this reaction is the acetic acid, and we add some baking soda to it, and we get an eruption out of our glass, our volcano, our beaker. You're producing these two products, which carbonic acid very quickly decomposes, so momentarily you get this, but then you form liquid water and gaseous carbon dioxide, along with this product, sodium acetate, which is soluble in the water. Now, this is a chemical change. A chemical change is one in which you have altered your starting ingredients and you have made new substances with a new chemical identity, a new chemical formula. For example, carbon dioxide is a gas at room temperature and pressure. These, I have some carbon and oxygen, but it's not in the ratio of 1 carbon to 2 oxygen, and it certainly isn't in the gaseous state. Same with water. H2O in pure liquid form, yeah, I have some hydrogen and oxygen, but they're not in that same ratio. The ratio of elements in the bonding delivers a new substance with totally new chemical and then physical characteristics. Here, sodium is bonded to just the ratio of carbon, hydrogen, and oxygen in this way. See over here, sodium is bonded to hydrogen, carbon, and oxygen in this ratio, in this way. So this is representing a chemical change. My substances are undergoing a transformation in their chemical identity. So, all of these are physical properties. These descriptions are made, these observations are made, and these chemical identities are not changed. But if we would say something like, acetic acid reacts with, here, let me just write this by itself so it's not cluttered, with sodium bicarbonate. Now, we will get to know chemical formulas shortly. So, of course, if you would read either the formula or vinegar reacts with baking soda to produce carbon dioxide or a gas. All right, so vinegar reacts, that's kind of a clue that you're transforming, you're undergoing a chemical change with this to produce carbon dioxide gas. You are producing a gas where you didn't start with it. That definitely, saying that this reacts to produce that is a chemical property. Not only a chemical property, of course, of acetic acid, but also a chemical property of sodium bicarbonate. To say that paper is flammable. Now that is a description of this, but I can only make that description when I'm trying, or this is undergoing a chemical transformation. You definitely know when you burn paper, you get something with a totally new chemical identity. What about acids react with bases to form water? Well, I don't think an acid is water to start or a base is water to start, so it looks like I'm forming something new than what I started with. So if this, I'm describing the behavior of this chemical property of an acid, chemical property of a base. So, physical properties, There are observations, descriptions like color, mass, volume, the state of matter, melting point, the density, that you can make that observation without changing the chemical identity. But a chemical property is only seen when that substance is undergoing a chemical change. So, we're looking for clues in the description like reactivity, flammability, change of charge. That will come to light to come. So, we can change matter chemically, and the reaction of baking soda and vinegar involves that. But what about, like I talked about before, taking solid baking soda and just liquefying it? We can see the chemical identity is the same, but I definitely have changed it. It is in the liquid state, starting in the solid state. It's gone through a physical transformation. Well, that is a physical change. I can take a piece of paper and tear it. It is still paper, but now it's in two pieces where it started with one. I can crumble it. It is still paper. So that is a physical change. But if I burn it, that's a chemical change. So if we take a look, if you want to pause, this talks about physical changes and chemical changes. Some examples of physical and chemical changes. Can we take a look here? Often there are clues in the change that let you know, you're forming something new. Chemical changes always involve a change of energy. So that could be released as light, or it could be released or absorbed as heat. Now, we can get a little sticky whenever we're undergoing a temperature change. Most times, to go from the solid to the liquid state, we have to input heat energy. We are inputting that. It is not in and of itself releasing or producing. We're adding that. So we have to just be careful making these judgment calls. If the process in and of itself releases heat, if the beaker gets warm and we haven't done anything, we're seeing probably a chemical change. Do you know that when you react vinegar and baking soda, the beaker actually feels cold and you haven't put it in the refrigerator or freezer because that process is endothermic. So if the process in and of itself feels colder or feels hotter, it is releasing or absorbing heat. That's a good clue that it's a chemical change. Now, often you produce solids where they were not before. If you produce a solid from two or more solutions, that's called a precipitate. That often involves the creation of something that's a different color. So sometimes authors will use color change to mean you've created a precipitate. But we have to be careful because a color change doesn't always mean a chemical change. So after this video, you're going to practice classifying chemical and physical properties, chemical and physical changes. And the question is, to make that observation, did the substance undergo a transformation in the chemical identity? If it did, it's a chemical property. If it didn't, it's a physical property. These are transformations. If the transformation produced something new with a new chemical identity, that's chemical. If it didn't, then it's physical. We will get near and dear to these in every single lab that we do for the entire year and every single aspect of progressing in our learning of chemistry.